Hello, everyone. I hope you are enjoying this conference. We have here Zan Markan, directly from London. Zan, how are you?
I'm good, thank you. How are you?
I'm fine. We are so glad for having you here. Thank you so much here in Porto and Portugal, of course. So I will let you speak in the end, please, guys. We have a Q&A, so feel free to write your questions on chat, and I will try to pass to Zen. Zen, good luck, and it will be so nice to hear you.
Thank you. Thank you very much. All right, let's begin. So today we'll be talking about CICD and how to succeed with it or not fail through some practical tips and tricks. Hopefully stuff that you've not heard or not seen before. But let's begin with a little thought exercise. Imagine that you're getting ready to ship a piece of software, something that you worked on for maybe a week, maybe a couple of hours, maybe a couple of months. It doesn't really matter. But what matters is that you've prepared everything. You have all the tests that are passing, everything is ready, all the release preparation has been done. All you need to do is to press this big red button and the thing goes live. So imagine that you do press that big red button. It has a nice tactile feel to it, has a nice like mechanic keyboard style click, and then it's out of your hand and off to the races, if you will. So yeah, you've pressed the button, everything is kind of being deployed, everything is being released, it's out of your hands. You don't really control the process anymore. It's very hard to stop it at this point. And yeah, all you can do is kind of sit back, wait in silence, and yeah, then you have really two options for what to do next. Option one is, yeah, keep sitting in silence and holding your breath maybe until you go blue in the face, nervously waiting if it or how it's gonna blow up or how it's gonna like start breaking to your users, maybe through like errors that you're gonna start seeing, or yeah, just kind of like reports of something going wrong. Or B, you pack up your stuff and go home. Maybe have a couple of beers because it's Friday at 4 p.m. and you've done your work, you've done your release. I definitely prefer option B. I don't know about you. I do hope you prefer option B as well. And the difference between the two is actually quite small. It really just boils down to the automation that you have in place, how much automation you have in place, and how much do you trust your automation that you have in place. And to be honest, it's always the case, whether you're talking about software, obviously, or whether you're talking about some kind of manufacturing, whether you're talking about some kind of other manual like processes that you're trying to execute, or in fact, the agriculture as an industry as well. Like even agriculture is greatly dependent on automation and in how predictable the results are going to be. So yeah, this talk is not about agriculture, but I do like to compare software with agriculture just because of that. So imagine you have this kind of huge field that you want to grow some crops in. So you can have this field and have nothing automated whatsoever. So you can have like tens, maybe hundreds of people working this very field, trying to kind of plant everything, water everything, then pick everything, do all the weeding, do all the plowing, all done manually. Or you can invest in some machinery, maybe some tractors, maybe some other kind of specialized type of machinery like harvesters. you can maybe put in some irrigation systems in place that will allow you to do more with less people, and B, also achieve more predictable results, because like the tractor is just going to go through the whole thing, and you can guarantee that all the rows of plants are going to be like plowed exactly the same way, or like worked on exactly the same way. The same with irrigation, right? You don't rely on just water, like rainfall to fall. You can actually make sure that every plant gets exactly what it needs. Or you can take this a few steps further. So you can actually invest in something like a greenhouse, highly specialized, highly mechanized greenhouse for that matter. So I imagine this one in particular has some kind of humidity control, temperature control, light control going on, so that every single variable that was kind of up to the weather in the previous example, this is kind of all controlled in this case. And I imagine each of these plants have like direct feed of nutrients directly to them, so that it gets exactly what it needs at the right time it needs. And these cool little more giant robot hands, I presume they use some kind of computer vision to pick and pack each plant as it's the ripest, basically, so you can actually sell it at the greatest profit, and again achieve the most predictable results that you can, even with something as live as growing a plant. And that's what I like to compare with really well-tuned, well-automated CI/CD process, because you're kind of controlling for every single possible variable that you can with regards to how your software is being built, how your software is being deployed, and so on. So everything is kind of fully automated, fully controlled, fully predictable, and fully reproducible. But yeah, obviously that means that everything is always going to work perfectly. Of course not. Sometimes machines may misbehave, and while I don't think that your robot arms in your greenhouse or your CI/CD system will turn into these kind of giant robot dinosaurs anytime soon, at least, it can definitely ruin your crops and your CI/CD system. If you fail a deployment, if you deploy something with like faults, essentially, you can ruin your user's day and definitely your own day. But fret not, it's never the machine's fault. It's in fact, it's always our fault, because we are programming these systems of automation. We are programming these machines, and yes, the problem exists between keyboard and chair, and that's the unfortunate and fortunate truth of everything related to software, including automation, of course. My name is Zan Markan, speaking of problems that exist between keyboard and chair. I'm a developer advocate at CircleCI, and it's a great pleasure to be here speaking to you today about CI/CD and best practices. I'm pretty active on Twitter, so if you want to follow me, that would be great. If you have any questions, obviously I'm available on email. I'm available on social as well. Anyway, as I mentioned, I work for CircleCI. We're the leading CI/CD platform out there. And we've been going on for a little over 10 years now, growing all the time. And we help teams all over the world, of all sizes, in all types of organizations, build and ship code and validate essentially their changes better, faster than they would without us. Regardless of what kind of programming languages, regardless what kind of technology they're using, or what their kind of development practices really are. But this talk is not about CircleCI. This talk is about CI/CD in general, and the practices that you can follow. So I'll give you some examples of how we do things in CircleCI, but it's pretty much all agnostic to the technology, what you might be using, how you might be using it, and so on. Anyway, for those who might not be familiar with the terms, CICD is a double acronym that stands for continuous integration and continuous delivery or deployment. And CI, the first part of it, essentially means continuously validating and testing and building the software as the commits are pushed to a shared code repository. So for example, if your team is working on a GitHub repository, every member either works on the same branch or works on the single, like trunk-based branch. They push commits to the repository, and then this kind of triggers this CI pipeline or CI/CD pipeline, which CI is one part of it. And this then executes a set of scripts, a set of rules, essentially automation rules that describe what tests need to be run, how they need to be run, in what environment they need to be run. That's the kind of greenhouse example before. So the idea of running everything in a CI/CD pipeline is to specify exactly the type of, for example, container that we want to build our software. So this is the Docker container, the Docker images that we're going to use, exactly the type of software it has. It's version locked as well, so you always get the same version for that particular version of software. And then that gets built and tested in isolation. So you don't have any dependency issues. In theory, you don't have any dependency issues, but you don't have to stop at tests like unit tests, functional tests, integration tests. It can do all types of verification, validation that you might have in place. For example, security scanning, we'll touch on that a bit later. You can have static code analysis, you can have linting, and so on. And you ultimately build the software into a final binary, whether that's a desktop application, that's a mobile application, that's a container that you're building. It doesn't really matter. The process is pretty much always the same. What matters is that it kind of executes as commits are pushed and based on some kind of rules that we define. The way we define these rules, in CircleCI in particular, we use YAML to kind of write YAML files, which are part of that same repository. So they're part of that same application that you're working on or system or whatever you're working on. And essentially they're tied to the same commit. So you write your workflows, you write your jobs, steps, and so on. And that's kind of tied to the same commit. So again, like always reproducible because your commit is not going to change. So you can always kind of go back to that commit, trigger it again, and it should, in theory, pass every single time or fail every single time with the same results. So that's CI. That's like, we'll give your development team feedback, hopefully as quickly as possible, of whether, yes, the changes that you're trying to push or you have pushed are good or not good. So you get like the feedback of like, hey, go fix your test, you go fix your build, something has gone wrong or something has passed. And ultimately it'll result in a built piece of software, which takes us to the CD part of this, continuous deployment or continuous delivery, which is essentially the practice of scripting the rest of the release or delivery process. For example, we've built our image for a Docker image, for example. And now we want to deploy this to the environment, whether that's production environment, whether that's a staging environment, development environment, testing environment. It doesn't really matter. It doesn't really matter what kind of software we're building, as long as, yes, we are kind of setting up and writing the exact steps that need to happen in a reproducible manner, so that, yes, our software is ultimately delivered to the users. And they can obviously be end users, they could be testing users, they could be stakeholders, and whatever the platform is, whatever the place you're deploying to, static websites, Docker images, Android, iOS applications will go to obviously their own stores. It doesn't really matter, as long as it's kind of scripted in a way that's automatically executed based on some rules. Obviously, you don't want to maybe deploy every single time. Maybe you just want to deploy based on a branch or branch name or a tag name, for example. Anyway, that's CI/CD in a nutshell. So everyone should have a good idea of what we are talking about. So as you might imagine, there is a lot of moving parts. Like there's all the tests that we need to run. There is all the verifications. There's all the deployments processes that need to happen in this kind of CI/CD process, in the CI/CD pipeline, the way we call it. That's quite kind of big piece of information to hold in your head. So let's break it down into various dimensions and look at how to be successful in each one of those dimensions. So yeah, let us begin. First one, and what is usually comes first to mind to most people when they're talking about having a good time with their CI system, especially the CI part of it, or having a bad or terrible time with their CI system, is how fast it goes. And yes, it's easy to compare it with a racetrack. We've got these kind of formula races where you obviously want to go as fast as possible. So yeah, let's tackle speed first. And yes, obviously, time to run a CI/CD pipeline, especially the CI part of it, because that's the validation, that kind of the verification that kind of gives you the quick feedback. As a developer, we want that feedback to tell us, yes, your tests have passed. You can continue working on the next ticket, or like continue just kind of building that feature out that you're working on. So as soon as we get that feedback, the less time we spend waiting on things, and the less time we actually spend on doing things that aren't necessarily really productive. And honestly, you want to do things that are productive as a developer, I hope. But that's just one part of it. So that's just time to run the CI/CD pipeline. The other one is recovering from a failing build. So as I said, like sometimes your build will fail, and that's completely fine. Your tests have maybe failed. Maybe there's some scripting things that are wrong. Whatever it could be, sometimes builds fail. If it happens on a feature branch, if you're following like Git flow type of process, I mean, obviously you need to get that back to passing before you can do a pull request. Or if it's happening on your main branch that you're using to kind of then deploy the software, then you have a lot bigger problem, because you cannot actually build and deploy a broken software that's not got its test passing, because it doesn't have your tests passing. It's not validated automatically. So yeah, time to get that kind of failing or red build to recover is very, very crucial. And we'll learn how a CI/CD system or platform that you're using can help you do that. The others are, yeah, more organizational based. So like time to actually ship a feature. Obviously, we're just kind of writing some automated scripts. How does that kind of help our organization? But if you're thinking about it, if we know constantly that our changes are being validated, changes are being tested, and our software is being built all the time, then that gives our organization the confidence that we can actually ship it as soon as we know it's been tested. And so it kind of gets down that time from when your product manager, for example, gets this mandate to build a new feature to actually getting that feature to your users, because you're kind of making all of those kind of tests, security scans, and so on as quickly as possible. So you kind of get this organizational benefit as well. So yes, you can start selling that new feature as soon as you can get it. And if that release time is a week from starting to finishing, to deploying it, to releasing it, versus if that time is maybe 6 months in some cases, in some organizations, that's a big, big difference. And also things like time it takes to onboard a new team member. So if you've kind of added a new team member to your team, maybe they've come from a different department in the organization, maybe you're just hiring someone anew. and you have your own kind of set of tests that you're running. You obviously have your own application, has your own kind of like rules and verifications. It's very easy to then just point them to your CI/CD configuration. As I said, like it's a file that's part of the repository, and tell them, hey, read through this. You'll understand which tests are being run, how we're calling those scripts, which scripts are being called as well. And where are we deploying this? Are we deploying this to some kind of like production environment, staging environment, and so on? And they will have a new set of questions, but they won't have that initial kind of gap in understanding what the big picture is. If you kind of just point them to this CI/CD pipeline and tell, hey, read through this, and then we can discuss each different step on their own. So yeah. These are like different sub-dimensions of speed, as I like to call them. So yeah, running your pipelines faster. Now we're more like in our first kind of more practical part of the presentation. Obviously, we want to run things faster because we want to get the feedback as soon as possible. First, and the easiest thing to do is use the right resources and resource classes for the job. In Circle CI, we have this thing called resource classes, which tells us how much essentially power you're giving to your machines that are executing things, whether they're virtual machines, whether they're Docker containers, whether you're giving it 8 gigs of RAM, 16 gigs of RAM, or more, or less for that matter. So if you have, for example, a build that takes like 5 minutes on your local machine and 15 minutes on your CI, that's probably because your CI is dealing with a lot less resources that your local machine, local laptop, for example, has. So up that, it's like one line change essentially in the config, and that will potentially kind of give you significant speed results, speed improvements, and you don't need to do anything else. It's just like adding more resources. So think whether you have something like that going on. And obviously, if you're running into out of memory errors, if you're running into like if you know that your, for example, compilation can use multiple threads, so add multiple virtual CPUs, and that will kind of make this whole thing go faster. Obviously, if you have a non-cloud-based solution, that might require you to actually go and buy more RAM for your builder machines. But if you're using a cloud-based solution, it's a lot easier. Then there are a couple of techniques that we can take that will actually speed up things a lot more in a more logical, programmatic way. First one is caching. So what's caching? Caching is deduplicating the work that you're doing. So for example, what does each kind of compilation require? First, you need to get the dependencies. So if you know that those dependencies haven't changed from one run to the other, then you can actually just cache those dependencies. If you're using, for example, node modules, you can cache or npm, for example, if it's a node application, you can cache node modules. If you're using Python, there is their own dependencies. If you're using Maven for Java, you can cache those kind of dependencies. Each system is different. Each system will have its own kind of place where it caches things, but ultimately you can store those and then basically compare from each run to the others, like how your dependencies descriptors have changed. For example, in Node, you have package.lock that you can check and then compare it with the subsequent one. If it hasn't changed, you can just reuse those dependencies very easily. Python has requirements, Maven has its own thing, and so on and so on and so on. And that's just one type of caching. The other type of caching is caching things that you've done already within that single pipeline. So for example, if you have a job that builds your software, and then you have a job that runs your functional tests on that piece of software, maybe build it once and then pass that built artifact to the subsequent job that will do all the functional tests, for example. That's a very easy way to kind of get this done. In Circle CI, we have the concept of workspaces. So you basically attach a workspace to one job, copy what you need, and then reattach that workspace to the subsequent job. So kind of pass those things along. The other thing you can do is store artifacts or store like even build intermediary build artifacts that might speed up your build a bit more. So that's caching, obviously saving you a lot of time by not doing the work twice, because if you're done it once, you can make sure that it's kind of been done properly. So that's caching. The other one is utilizing parallelization. So if you're thinking about what tests, what verifications you want done, for example, you want your unit tests, your integration tests, your functional tests, but also security scanning. You want to build your final artifacts. Like, when does this need to happen? Does it need to happen sequentially, or does it need to happen, or could it happen like in parallel? Start all of the things in parallel, and then kind of collate the results in the end. So I would argue it's always better to start things in parallel, so that, yeah, you're not kind of having 1 minute job and then add 5 minute like integration test job, and then some kind of security scanning job which takes another 2 minutes. Instead, start them all at the same time, and it'll all finish at the time the slowest single job finishes. In Circle CI, that's pretty easy. It's like by default, you define your workflow essentially, which is a collection of jobs. They will all start at the same time if you don't specify explicitly that you need one for the other to continue. Then the other type of parallelism, the more interesting type of parallelism, is tests, basically. So I've dealt with a very long test suite in the past. For example, we had an Android app that was running for like 4 hours, basically a single test run. And it's actually possible to split or shard those tests so that you run smaller portions of the whole test suite in parallel and then kind of combine all the results together. This will depend on, what kind of build tool you're using, what kind of testing framework you're using. Usually each testing framework has an option to take individual or to specify individual files. So if you have like maybe 20 test files, you can then kind of pass like subsets of those. And there are tools that help us do this more effectively, more automated. For example, we have a feature called test splitting, which basically lets you define which files these are, and then pass this to Circle CI, which will kind of split those files across the number of jobs that you say you want to run in parallel. So it's like 2 lines extra, or maybe 3 lines extra of code, as opposed to just running npm run test. You're kind of adding these kind of couple of lines. I've got some examples. If you're interested, you can reach out to me afterwards and I'll share it with you. And yeah, like you can get like a 2-hour job down to, I don't know, a few 20-minute jobs, or like 5-minute jobs even, if that's possible, by just kind of running things in more parallel. It's very, very powerful, especially if you're dealing with a long running single suite of tests. And ultimately, you get to pick what runs at which point. For example, you have all these different kind of types of tests, all these different types of verifications, but maybe you don't need that if you're just working on a feature. Maybe you're just interested in the unit tests of your feature. Maybe you don't want the whole integration tests. You just kind of like figure out, yes, this is working on a branch. Maybe I don't want to run this on a feature branch. Maybe I just want to run my tests on like my functional integration test suites on a main branch whenever this is being issued as a pull request, or whether it's being merged. Or even maybe you have like a nightly job that tests all of these kind of expensive long running operations, so that you kind of split it outside of the development process. So yes, your developers can move faster because they can develop things a lot faster, and your QA team is still happy because they still get all the validation required within a reasonable time frame. So yeah, running pipelines faster. A couple of techniques that can really speed up your builds with not that much of investment. Obviously, we talked about how things sometimes break. And yes, if things break in your main branch, that means you have a problem, because that main branch is not something you can take and build and ship. So you get stuck with something that's blocking essentially your whole release process. So you can't get an urgent bug fix through because you can't deploy anything, because your deployment is stuck with like some failing tests, for example. So how do we tackle this? There are ways. There are always ways. So yes, recovering from failures, another thing we need to deal with as quickly as possible, probably the most urgently. First is understand how you can get information from your build. So understand which part of the build is failing. Obviously, that's like a single job that might be failing on tests or scripts or whatnot. But also which type, maybe it's like a script that's failed and whatnot, like understanding that. There is usually some kind of dashboards available in a CI/CD system. We have one called Insights, basically, that kind of tells you, yes, exactly, this has gone wrong. And this is where you get the logs. This is where you get all the information. Speaking of logs, understand how to log everything. This will greatly depend on whatever programming language, whatever platform you're using. But yeah, understand, like, how do we turn on debug and verbose modes for everything? Like your build tool, Gradle will have its own thing. Maven will have its own thing. Ruby Rails will have its own thing. Whatever application you're building, understand how to toggle those logs, how to read those logs as well, because that's like very agnostic of the CI/CD system, but it will give you the ability to then kind of analyze those results and get to the conclusion and to the conclusion of what needs to happen, what you need to fix, or where you need to actually focus your efforts as soon as possible. So this includes, yeah, from build tools to programming languages, everything that might fail, get that. And then obviously not just print those logs in the like standard output, like terminal, but also have the ability to store those logs in a file, so that you can actually pull those out from the CI/CD system and maybe use cat and grep to process these files, to actually analyze where has the issues gone wrong. Because if you have a debug or verbose kind of log from some build tool, you will have a lot of stuff in there that you're not interested in. So having this kind of knowledge of how to process these files is very, very, very useful. And it's not something you want to be doing whenever there is like an urgent failure. So it's something you want to invest in beforehand, just like understanding how this works. And the same with build artifacts. So if you're building an application that's failing some unit tests, failing some functional tests, for example, maybe get that application out and try to run it on your local machine. Again, like how to store your build artifacts, how to get them out is a valid thing to know. And then lastly, one of my favorite things you can do, a few CI/CD systems have this, it's the ability to debug your jobs as they are actually failing. So we have this feature called rerun with SSH. So you're running this job and you're essentially rerunning it where it toggles SSH access to the running container on or running virtual machine, so that you can actually go in there and explore what's actually going to happen. So instead of kind of trying to do like multiple commits, trying to do one single change and then waiting for it to happen, you can actually just go in, poke around, see, okay, these tests have failed because of that. This file is missing. This directory is in the wrong place. So yeah, just see if there's features like that in the tool that you're using, and yeah, just kind of try to see whether you can use them for your good. Obviously, that's just one part of recovering. So you need to also kind of understand how you're getting those, like how you're going to fix it, but that's kind of part of the development work. Anyway, you know, when I said that it's very similar to a race, it's actually not. I lied, or I deceived you, because it's more, CI/CD speed is more about being an ambulance than being a racetrack, because it's good to go fast, but you also need to make sure that the signal you're carrying is fast enough, is also still there. So, because your payload, your test validation is the actual signal. So the faster it goes, the less tests you're actually running. So kind of find that balance between fast and thoroughly test it, and then run that in a way that makes sense for you. And obviously, yes, when you see red lights flashing, go fix it as soon as possible, because that means something has broken. Speaking of broken things, one thing you don't want to break is the security of your application. And there are a few things that we can do. First off is make sure that our credentials are safe and outside of the repository that we're working in. So I shouldn't be telling you this, but if you do have some credentials, some API keys in your repository, take them out as soon as possible, change them, rotate them, and stick them in your CI/CD system, because your repository is inherently unsafe. Anyone can get access to your computer and then get access to your keys, which is going to be a bad idea, bad time for everyone. So every CI/CD system has a way to inject variables at build time. When the job is running, it injects them as environment variables. So yeah, utilize that as much as you need, as much as you can, to kind of keep them safe. On the CI side, they'll be encrypted, and yeah, only injected when they are needed. I've talked about this before, automating security scanning. So there's a whole industry about this. It's called DevSecOps. And the term that they throw around is shifting left. So you shift the security processes left to where the code is actually being written. And that's essentially automated security scanning. So whether it's scanning your dependencies for malicious packages that you might be integrating, to scanning your actual kind of containers that you're running, maybe running like some static code analysis to see kind of unsafe patterns. You can actually do these as part of your kind of CI/CD pipeline that validate your security of the app before it's actually reaching the users. You don't think about reaching your users. You can actually fail your build saying, hey, your package dependencies contain something that's deemed unsecure. There's plenty of tools, plenty of companies doing that out there. And I would definitely recommend you kind of put that as part of your CI/CD flow. And lastly, think about how to split responsibilities and split any credentials and access to any credentials between your jobs that you're running as part of your pipeline. For example, you may have like different deployment jobs, like deploy to production, deploy to staging, deploy to development environment, and they all don't need access to the same set of credentials for like AWS keys, for example. So you just want to split those credentials through to each individual job that's executing them. In Circle CI, we have this thing called context. Basically, you specify this is a production context, this is a deployment context, and it'll only have access to the credentials within that particular context. Super valuable, especially when you're kind of also using other types of tools that do your security scanning, for example, or do your code analysis in some other way. that you don't need access to kind of all of these kind of production keys, because they are the most valuable things that you have. And also you can split responsibilities to who actually can do the deployment, who can actually go through with the production deployment. You can actually say, this is only for our delivery lead, if you're as part of more of an enterprise organization. This is part of delivery leads work, or this is part of the development team's work, for example. And only that person will be able to trigger the pipeline that runs until the end, which is super, super valuable. So yeah, so we've kind of covered all of the different tricks of the tool itself, but what happens beyond the CI/CD tool? Because yes, your team is mostly working on code, but you're also working with external tools and external teams that you collaborate with. For example, you might use Slack for your team to communicate. So especially for your operations team that kind of handles software when it's running in production. So you can actually use your CI/CD kind of results or your workflows that you're defining to kind of inform people with Slack that yes, a deployment is being done to production. Keep an eye on this if something is going wrong. So you kind of let people know as soon as you can, without developers having to do that manually. Again, all in the name of automation. You can also get it out to external dashboard or metrics tracking services by just kind of telling them, hey, a new deployment has been made. We have this going on. You should see like stats when it goes live, what's happening, and so on. The same with, you have your product ticket tracking tools, for example, Jira. You can have your deployment information in Jira. Say, yes, this deployment has fixed this bug, kind of all automated, so that yeah, you don't have to kind of log in and kind of click a button and so on, which is again very, 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 very valuable. And yeah. Lastly, there might be features in your CI/CD tool itself, because that have been released in the last few months that you haven't touched it, basically. So if you're not done any modifications to your pipelines, maybe there's been some features that have been released that would make your life a lot easier, your team's time a lot better. So I would recommend you just read through the release log or release notes every few months and see, yes, maybe there is something in there that's valuable for us. Speaking of teams, like there's no DevOps talk without talking about teams, obviously. And we work best when the team is all on the same page, all kind of all in sync with what's needed. And yes, CI/CD is absolutely always a team responsibility. It should be a team responsibility. So it's not something the DevOps team does. It's something the development teams should actually own to some extent. So the best practice here is to really spread the knowledge as much as possible to avoid bottlenecks. Don't say this is something only senior engineers need to deal with. No, this is something everyone should understand. Like, as I said, you have a new team member, show them your CI/CD config. They'll ask you questions. They'll know, okay, this is actually what's happened. It's pretty easy to read. It's really easy to understand. And if something breaks while you're on vacation, maybe someone else is able to debug this because they have the knowledge. So that's like a very easy way to avoid unwanted phone calls when you don't want them, basically. So yeah, it's valuable. Just include everyone in the process, even if not everyone is an expert in CI/CD. It doesn't have to be, but as long as they know the basics of the tool, basics of the configuration, and how to kind of solve common issues, that's very, very valuable all the time. So yeah, we've done our deployment in the beginning, right? And we've done a deployment, and sometimes we actually break something, even though we have all the automation. And that's just the reality of life. Broken deploys will happen. But luckily, our CI tools can help us enable our fast recovery and reverts, because if everything is tied to a commit, a broken deploy is tied to apparently a broken commit that your tests obviously haven't caught. But you revert back to the previous commit, reinitiate deployment. That could be all you need to do to actually get the application back to working, which is really powerful idea to know. Especially if you need something back as urgently as possible. It'll also help you favor smaller changes, because you can do deployments multiple times a day, because you can actually, you're sure that you're validated all the changes. And yes, that's live now, so very easy. But ultimately, best plan is to actually have one and practice it. So have a dry run of a broken deployment every once in a while, and yeah, maybe once per quarter, see, yeah, we've broken this. Let's say we've broken this. How do we revert this? Have a playbook, read through it, go through it, and understand, so that, yeah, everyone on the team is on the same page. Everyone knows what's happened. Anyway, the point I'm trying to make, that if you're successful with CI/CD, it means that it brings you a lot of freedom in how you're actually building software on your own terms, in the way that makes your team happy, successful, and obviously allows you to ship more higher quality applications. Allows you to adapt to change faster from an organizational level to the team level. And yes, you get a couple of really, really nice benefits, like self-documenting, build, test, deploy processes, and a lot easier recovery from failure if everything is automated. Anyway, my name is Zan Markan, and this was some practical tips for CI/CD success. It's been a pleasure.
Thank you so much, Zan, for this huge explanation. Your talk was really good. Thank you so much in the name of Porto Tech Hub. Okay, Zan?
Yeah, thank you.
So I have two questions here. The first one is Juan Pereira. Juan Pereira asks you, what do you think about IA machine learning on CI/CD to help or automate some decisions?
So if I understand this correctly, how would AI and machine learning help automate some decision? Okay, yeah. We actually rolled out a feature in Circle CI in particular called flaky test detection. So basically that uses machine learning to essentially gauge whether a test is flaky. So for example, if it's failing some of the time, but not all of the time. So that's like one way you can actually use it, but it's kind of under the hood. But it's definitely very valuable. It's been like, we've had really good feedback so far to just kind of analyze this. The others is, I mean, that's probably the biggest one, I would say. Obviously you might like GPT-3 and Copilot are becoming a thing now. So maybe you can get something on the writing of software as well. But yeah, that's kind of not quite related to CI/CD in particular. But yeah, I would say like things that machine learning is really good at is just sifting through a large quantity of data. So yes, kind of flagging slow builds or like anomalies. And yes, obviously one of those include flaky tests. I hope this answers you.
Thank you so much, Jen. We also have another question from Marcelo Souza. Marcelo is asking, can you see a future then of CI/CD without pull requests?
There already is CI/CD without pull request. It's called trunk-based development, where basically you don't work on branches, you work on a single branch, like a main branch, and every developer is committing to it. It's a completely different way of working to, like, you might be familiar with like Git flow and so on. And it also requires a lot more discipline, essentially, because yeah, every single commit is is for real. Every single commit is going live, basically. So yeah, and for that, obviously, you need a lot of discipline in your team. It helps if you have like pair programming in place at all times, because you kind of catch any kind of small issues beforehand. That's like one of the possible features without pull requests. I personally am not completely on board with it, but there's definitely teams that do it very, very frequently, very successfully. So yeah, it could be something you might be interested in. But yeah, obviously, I'm not talking about kind of different ways of building software, writing software in general in this talk.
It's really nice. Zan, some people are saying great presentation and thank you.
Thank you.
In the name of everyone that was assisting to your presentation, I want to thank you very much. Well, we still have time for another question. And the last one, I will say, Israel Orient is asking, what do you think of Cypress? Is it the best thing for testing?
It's a thing for testing. And it's very popular. Definitely, Cypress is a web testing tool. I've not used it myself, so I don't have much opinions about it. But I know there's a lot of people using it with our platform. So yeah, they seem to be enjoying it.
Then thank you for answering. Thank you for your time, and thank you for sharing so much knowledge with us. It was an awesome presentation.
It's been a pleasure. Thank you very much for having me.
Guys, we see you in the next talk.
Bye.